Hello, and welcome again to FlippedHarber for Algebra 2. In this video, we're going to be talking about Section 1.8, Exploring Transformations. Now, transformations are actually going to be something that we revisit quite often throughout this entire year. So, our objectives for this lesson are to learn how to apply transformation to points and to sets of points. Basically, we're talking about applying them to individual points and to graphs. We're also going to try to figure out how to interpret transformations of real-world data. It's just a fancy way of saying story problems. Our topics for this lesson include transformations and the different types of them: translations, reflections, stretches, and compressions. In this video, we're going to take a look at each of those types of transformations, and then we'll cover some examples. Now, the different types of transformations that there are include translations, taking points or graphs and moving them up, down, left, or right, or some combination. Reflections mean that we take a mirror image, and we limit ourselves to looking at reflections over just the y-axis or just the x-axis. Stretches are exactly what they sound like. We take a graph or we take a point and we pull it away. Compressions are the exact opposite. Now remember, all of these transformations can be applied to single points, several points together, or entire graphs. Now, our first type of transformation, a translation. We have two types. We have horizontal translations, moving a point or a graph left or right, and we have vertical translation, moving a point or graphs up or down. We accomplish this with single points by just simply changing the x-coordinate if we want to move it left or right. If we add to the x-coordinate, we are moving the point to the right. If we subtract from the x-coordinate, we're moving it to the left. Similarly, if we want to move a point up or down, we change its y-coordinate. If we want to move a point up, we add. If we want to move a point down, we subtract. Reflections, again, we're limiting ourselves to reflections across either the x or y axis, happen by changing a negative value to a positive or a positive value to a negative. If we want to reflect a point across the y-axis, we actually change the x-coordinate. If it's a positive number, we change it to a negative, and that's going to reflect it across the y-axis. If we want to reflect across the x-axis, we do the exact same thing to the y-coordinate. So again, if we want to reflect over the y-axis, we change the sign on the x-coordinate. If we want to reflect across the x-axis, we change the sign on the y-coordinate. Stretches are where we take a graph or a point and we move it away from one of the axes. If we're talking about a horizontal stretch, we're talking about stretching the graph away from the y-axis. Now, any points on the y-axis stay where they're at. So if we want to stretch away from the y-axis, we multiply the x-coordinate by a certain number. So if we want to double, we multiply the x-coordinate by 2. If we want to vertically stretch it, we're going to multiply the y-coordinate. Again, a vertical stretch is pulling it away from the x-axis, so points on the x-axis don't actually get moved. Compressions are the exact opposite. We push points, we push graphs towards the y-axis or towards the x-axis. And again, a horizontal compression, we're changing the x-coordinate. For a vertical compression, we're changing the y component. Again, with a horizontal compression, any points on the y-axis don't move. For a vertical compression, any points that are on the x-axis don't move. Now let's take a look at an example where we're going to apply 3 different transformations to a point. Now, what I'm talking about here is changing the exact same point 5 to 3 different ways. I'm not going to apply one transformation and then apply another transformation after that. We're going to start with 5 to each time separately. So if we want to move 5 to 3 units right, that's a horizontal translation. We're going to add 3 to the x value. If we want to move 5 to 4 units down, that's a vertical translation. We're going to subtract 4 from the y-coordinate. And if we want to reflect the point over the y-axis, remember, we accomplish that not by changing the y-coordinate, but actually changing the sign on the x-coordinate. So this is what the point would look like after these three transformations. Now notice I didn't box in my answers. That's because it's in a table form. If your answer is in a table form like this, you don't have to box it in. So my transformation of 3 units right, I added 3 to the x-coordinate and I got 8. The y-coordinate stayed the same. To move the point down 4 units, I subtracted 4 from the y-coordinate and I got 5, -2. To reflect the point over the y-axis, I changed the sign on the x-coordinate only. So -5, 2. Okay, so let's get to a little bit more challenging topic, that is transforming a graph. Now, some of these transformations are going to change the way the graph looks. Some of them are just going to push them around on the paper. A translation is an example where the shape of the graph doesn't change. It just gets pushed around on the paper. So let's take this graph and translate the graph 2 units up. Now, one nice point to look at would be that corner. It's actually referred to as a vertex. If we stop and think, where would that vertex end up at if I moved it 2 units up? It's going to end up at the point 3, 0. So that's always a good point to start with. Is any vertices, any corners are good points to start with, and then build the graph around that. So let's take a look at what this graph is going to look like if we translate it up 2 units. So we see the original graph in the light pink. The new graph in the darker pink, we see that vertex has been moved up to the point 3, 0. The graph looks exactly the same, it's just in a different location. And that's always the case with translations. It doesn't change the way the graph looks, it just moves it up or down, left or right. Okay, let's take this same graph and let's reflect it across the y-axis. Now that means that any point that's on the right side of the y-axis is going to move over and be in the exact same spot, only on the left side. So again, let's talk about that vertex. That vertex is at 3, -2. Where's it going to move when we reflect it across the y-axis? That vertex is going to move to -3, -2. That line that's pointing up and to the right, well, it's still going to point up, but now it's going to point to the left. So here again, we see the original graph in the light pink, and we see the new reflected graph in the dark pink. The graph is in the same position vertically, it's just been reflected. Now let's take this graph and reflect it across the x-axis. Now in this case, that vertex point is going to move from below the x-axis to above the x-axis. And here again we see the original graph in the light pink and the new graph in the dark pink. Now, when you're doing your homework, you don't need to draw the original graph unless the problem actually says draw the original graph and then translate it. If they just say to draw a graph of the translation, just draw the new graph. You don't have to draw the old one. Now let's take a look at a story problem. This graph represents normal zoo admission prices. We're going to state the transformation to the graph that each promotion will cost. So we see our graph is what it would normally cost to get into the zoo. For somebody my age, it's going to cost them $7.50 to get into the zoo. But there's these promotions going on. Our first promotion is that prices are half off on Wednesday. So that means that everybody, no matter what their age, would pay half of what they normally would. So what kind of transformation is that going to be? Well, that's a vertical compression by a factor of 2. Another way of saying that is a vertical compression by a factor of 1/2. As long as you make sure you use that word compression, whether you use the fraction form or the whole number form, doesn't really matter. Now our next promotion is that all prices are raised by $1.50. So obviously things aren't going well at the zoo and they need to charge a little bit more. So what's going to happen to our graph if all the prices are raised by $1.50? Well, that's a vertical translation up 1.5. So instead of paying $7.50, I'm going to be paying $9 to get in and see those animals. Now our last promotion is that the maximum age for each group is increased by 5 years. So we're going to have the same price points, but everything gets shifted up. So what kind of transformation is that? Well, it's actually a horizontal translation right 5 units with a little asterisk. Now the reason I put that little asterisk is obviously you can't move that point for kids that are 0 years of age. Are we just not going to let those kids in? So it's kind of an altered horizontal translation. But the idea with the problem was that this is a horizontal translation right 5. Okay, so we're all done with this lesson. Here's your homework, and I want to remind you that this homework includes graphing, so please remember to do those graphs on graph paper and follow all the rules. I hope you've enjoyed this lesson. I'll see you in the class, and I'll see you online.